For this experiment, we will be finding out the relationship between the input frequency and the output obtained. The initial conditions for a 3-phase motor will be at 0 Hz frequency, 415 volt from the 3-phase power supply, and a load of 200 watts. The motor is in star phase connection, meaning one end of all 3 windings are connected together to form the neutral. With the input frequency at 0 Hz, the ammeter will show an output of 0 ampere and the rotor speed is at 0 RPM. Starting off with an input frequency of 25 Hz, the wattmeter will show 175 watts. The ammeter will show about 1.56 ampere. And the rotor speed is at 744 RPM. As we slowly increase the input frequency to 35 Hz, the wattmeter shows 250 watts and the ammeter shows about 1.60 ampere. And the rotor speed is at 1038 RPM. With the input frequency increasing to 45 Hz, the wattmeter increases to 325 watts and the ammeter is at 1.63 ampere and the rotor speed will be at 1339 RPM. When we decrease the input frequency to 5 Hz, it will lead to the wattmeter dropping to 125 watts. And the ammeter will be showing a range from negative 1.87 to positive 1.87 amperes. And the rotor speed will be at 144 RPM. This experiment shows that frequency is directly proportional to rotor speed, with an increase of frequency leading to an increase of RPM. This next experiment is showing the relationship between rotor speed and light intensity. At 0 RPM, there is no cutting of magnetic flux as the rotor is stationary. As we slowly increase the RPM of the rotor, there is cutting of magnetic flux and voltage is generated. Thus there is an increase in the light intensity. As RPM increases, the rate of cutting of magnetic flux increases, and so causes an increase in output voltage, which results in a further increase of light intensity. As the RPM decreases, the voltage decreases, which leads to a decrease in the light intensity. We notice that when the RPM is low, the output current is not constant and is pulsating, showing both negative and positive current. However, when the RPM slowly reaches 260, the output current seems to be constant, and the problem ceases to exist.